And AMATIC is the American Mathematical Association of two-year colleges, and our core value is building expertise and exhibiting leadership in the teaching and learning of mathematics, and enhancing personal growth and improving teaching methods and effectiveness as a personally initiated lifelong responsibility. And for more information, please visit our website at amatic.org. And please note that the views expressed by the presenter are not necessarily the views of Amatic, and any commercial products mentioned by the presenters are not endorsed by Amatic. And now we're going to switch to Luke's slides here, so let me hide these for you. And let's welcome Luke in the chat room today if you haven't already, and I'm sure that you are all in for a great treat.
A yummy treat. All right, thanks, John. All right, so exploring math with Desmos. My name is Luke Walsh, Catawba Valley Community College in Hickory, North Carolina. I got my email here, lwalsh.cc.edu. I am on Twitter at Luke Selfwalker. And once in a while, I haven't been doing this too much, but over at my blog, she thinks I factor sexy.wordpress.com. So feel free to contact me or try to extend this conversation after the webinar. So there are a few things I want to talk about with Desmos. But before that, if you want to go back to some other talks I had back at AMATIC 2013 in Anaheim, which was a great time, I had OMG, Oh Math Goodness, Where Are Your Algebra Skills? I think, so this is a hyperlink, but you can go and check these out later. You go to my blog, you'll see those there. Talked about using Desmos in the classroom. And I was just recently at NCTM 2014 in New Orleans, the Big Easy. That was a great time. And I did a talk about understanding by Desmos design. Understanding by design is kind of in the news right now a little bit. Wiggins, the creator, that put out a pretty popular blog post describing what is conceptual understanding in mathematics. So you might have been hearing a little bit about that. So there are just a couple other talks if you kind of get excited about using Desmos, maybe some other ideas you can explore there. So my first goal for this webinar is just kind of show some of the basic features of Desmos. It is a free online graphing calculator that we will be exploring. So you can graph in color. It has 6 different colors that you can choose from. You can do dynamic animations. You can use sliders that are hands-free. Perfect way to just demonstrate transformations, things like that. I've started to use it more for just kind of recording notes. Students will send me emails so I can actually type in text, attach it to a graph, and send that to an email. Show you how to do that. You can use it for doing tables of data. So if you want to do some regression, well, it doesn't really have regression. I'll show you another way that you can do that. But just kind of looking at sequences for series. But yeah, it definitely has a table feature there. You can organize everything through folders. You can insert images if you want to take a picture of somebody shooting a basketball, a water fountain, have your students go on a scavenger hunt, look for some conics, circles and ellipses, show you how you can insert images into the graphing calculator. You can have students create an account, and you also could create an account and just save all your graphs via online. I like to use it when I'm creating my assessment as well. So I'll show you how you can just take a picture of a graph, do a screenshot, or save the image and put it into Word, LaTeX, whatever type of program that you want to be using. And of course, all these features are for free. So the graphing calculator is free for everybody. A great resource. You don't have to spend the 100 or so for the calculator. If you have an iPad, there is an iPad app. The iPad app doesn't have all the features that the online graphing calculator has, but you can use the browser version on an iPad. You can actually use it on a phone. You can use it on a laptop, any computer, so it's very accessible if you have that technology. All right, and then the second goal for this webinar, so the other side of Desmos is that they're starting to create some content. So after we look at the graphing calculator, I want to show you some teacher content. There's basically 4 different lessons that we can hopefully work together as a group here. We got about 27 people, so this could be pretty fun. But there's this group, this lesson called Pennies. We got another one called Desman. The function Carnival is great, and Waterline. So I can't wait to test those out with you after we look at the calculator. And in these, I want to show you how there's instant feedback when your students are doing it. You have aggregated data. You get to see what all the students are doing in real time. It's a great way to get the class working together, getting people into groups, and do like some formative assessment, which really seems to be popular right now. And these lessons can go from, I've used them in developmental math for this function Carnival, all the way up to calculus. So hopefully you can find, whatever you're teaching, you can find some way to maybe use these lessons and then go back to the graphing calculator. All right, so now I am going to go over to desmos.com. So here's the link, and I'm just going to start doing a screen share right now and just start looking at the website. So if John, if you could bring up the screen share, I will go ahead and start looking at the calculator. If anybody has questions while I'm waiting for the screen share about Desmos, I can maybe try to answer those. Oh, that's probably a bad time to ask questions because I just remembered I cannot see the chat bar. So, John, if you feel like there's a good time to kind of pause and ask me the question, I'll go ahead and answer it. So right now I cannot see the chat bar. I can only see my screen. John, can you chime in real quick just to let me know that the screen share is working and I can move on?
Yes, I can see your screen, so that's not a
Okay,
problem. And I will let you know if anyone asks a significant question while you can't see the chat.
thanks, John. All right, so here's desmos.com. You come to here. Oh, I can see the questions. Okay, good. So if you just kind of scroll down from here, you see staff pick. So here, if you're just looking for some mathy ideas, you can go to this section. Creating creative art projects are really huge. So you can look at some graphics, or you can just do some saved graphs to look at, see what people are doing right now. So if I just go to the creative art, you can see how people are creating some amazing things. Oh, look at the Sierpinski triangle that we got. Looks like a My Little Pony. Los Angeles Clippers, they seem to be in the news right now. Elmo, creativity. So the students are kind of making these projects. Remember that when they make these projects, I'll be these features here. But students are, this is all designed by mathematics. So students are having to understand domain restrictions. They're having to understand shading. They're having to maybe understand some parallel lines. So you can get students to get really motivated by using an art project. I wonder if this is based off the movie Up, because that kind of looks, that reminds me of the Up house. All right, so, but let's go back to just a normal web page. So right here is where you can just click launch the calculator. Now I am already logged in, so you can see those features over here where it just says Luke. So that means that I am logged in and I have all of my saved graphs. So over here is just some of the graphs that I have that I can maybe prepare before class, after class, maybe if you want. So here's one I did it with some circles. To prepare some type of graph before you class, bring this up, have students sharing. So this is the area of the green and the Yeah, the sound is cutting out. Feel here. I'm going to have to.
Yeah, I do hear the audio cutting in and out a little bit, so I don't know if there's something you can do to tighten up your connection or not.
Okay. Yeah, so it might have been with like the sliders and everything, and since I'm sharing my screen, it might create a little bit of slowness. So I'll just remember not to do too complex of stuff. All right, so back to here. So I showed you how you can open up some saved graphs before you go to class. Your students could save these. When you save a graph, you actually get a hyperlink up here. And some of the other features you might want to be aware of, if you've never started using Desmos, you can go over here and just kind of look at these tours. These little tours will just help you get started. So if I just do a looking at tables, it will try to lead you through just creating a table. So it's telling me to go over here to click. Okay, I can see these features: expression, text, table, folder, image. I'm going to go ahead and make table. I see this, it's 3. Go down, add some more data, 5 and 2. Awesome, try pressing enter, just fill in one more row. I'll go with 7. Last trick, hold it down. Now I get all these, I can change the color. So you have these little tours on the side. If you've never used Desmos, or maybe if you have, you maybe not aware of all the features. So you can be looking at how to use sliders, tables, restrictions, or even some more advanced tables. If you want to look at even more, you can use the Desmos user guide. It's just a PDF. You can look at the knowledge base, who's been asking questions. It's kind of like a forum area. You can just tweet to Desmos. I actually run the Twitter feed for Desmos, so if you ask some questions, I'll be the one them for you. So we try to always make sure that people are getting their questions, their questions answered. I'm sorry. So back to over here. So I think one of the nice features about Desmos, it feels very intuitive of what you're going to be doing. So if you just type in 2x plus 3, notice right away it was graphing. You saw different things. Even if I go back to x, and then if I go plus 3, that the students are kind of seeing how things actually develop. You can go back and input like a squared. So notice I didn't have to put like a y equals. Desmos is understanding that you just want to graph something. If you're wanting to change the window, you can drag around the Cartesian plane there. If you have your zoom outs and your zoom ins, I just said those backwards, or you can just go back to default. If you wanted to call this, you can call things as a function. You can call something as f of x equals x squared. If you wanted to maybe start talking about transformations, you can talk, well, what does f of x minus 5 look like? So you can automatically see, well, if I start subtracting number from a function, it looks like it shifts it down. Or if you to just do 5, if you want to do 4 or 3, but if you're going to putting in like a whole bunch of numbers, you can just say, well, let's just let this be the value of c. And Desmos is saying, well, c is not really a number. Would you like to make this a parameter? Would you like to add a slider? So once it adds a slider, then you can change this value and it updates it in real time. And let's see, I'll try to play the slider. The sound might cut out. Since I'm doing a screen share, but usually it moves a lot faster and like that. I think my computer's just a little bit slow with that processing there. But you can actually create a nice slider value and just instantly see, well, I have the parent function here, and here's my one with the transformation. If you would like to change colors, you can click over to here, hold it down like we did with the tables. You can look at maybe making that to be the dashed line so they can see, well, here's the one that's being moved and here was the one that we started with. You can switch something to any color that you want. So that's really nice. And maybe you would like to have it actually look at that y-intercept. So if you want to make like a coordinate point, so you could do 0, comma, c. Oops, sorry, I did minus c over there. So now you actually have a draggable point that you can move from over here. And instead of moving slider on the left-hand side, you can get students to be just dragging the point and actually making themselves change the equation over there. If you're in a computer lab, you can have students working, but a lot of times early on, I had to just show it up on the screen. Over here on the wrench here with the settings, I think a nice one, if you're just showing it up on your screen, is to use projector mode. And projector mode will make this area a lot larger for students to see. It also makes things a lot thicker and bolder. So that's really nice if you are not in a computer lab, if you just have a projector, but everybody in the room could easily see it. Going back to over here, you can see where you could switch to degrees and radians. You can just change your windows X and Y manually over here. You can switch to polar. You can just stay in Cartesian, things like that. So maybe if you wanted to try to maybe put this graph like on your test, maybe have students say, if this is x squared, what graph is this? So if you go over here to the share graph area, this gives you some options. You can email somebody this graph. If they're having some questions, you can embed it into a blog. Right here would be the hyperlink. But if you wanted to maybe put it into Word, you could bring up the image. And what this does is just kind of create a screenshot. So you can copy this image to your desktop if you wanted to do it that way. Usually what I do in Word, it has that snippet feature. So I'll do something where I actually get the part that I want to have like on my test, and I'll just have it take a picture of it, and then I'll put the image like that. So it's a really nice and easy way to get really good graphs on your assessment without having to do the cutting with the paper and the tape and all of that stuff. All right, so let's show a few more features. I believe that we were talking about using maybe some sign functions, maybe somebody's doing some trig. So if we do, we'll do sine of x. Notice that I can just go ahead and start typing and it brings up the function. If students aren't really familiar with just typing out maybe absolute value, sine, or some other functions, or just knowing what there is, you do have this keyboard down here that students can use. This is more based on if you were using a tablet. This is really nice. But if you just also want to see what the functions that are available, notice that you have your basic trig functions, hyperbolic trig functions. You got your calculus for doing the sum, products, derivatives. You have some interesting ones depending on your level of programming or math. So you have the floor function, ceiling function, mod, and so there's lots of things to kind of explore down here in this calculator. But usually my students just get used to just typing out everything. All right, so if I'm just looking at sine, so if you want to do a domain restrictions, let's say if I just want to go from 0 is less than or equal to x, which is less than or equal to, you can either do tau for 2 pi, or you can just do 2 pi. Notice that my x-axis is not in radians, so I can move up to here and just put x-axis there. And so students can really see that this is 0 to 2 pi. So some things that you could begin to doing then, if just going back to here and looking at the transformations of trig functions. If you wanted to say, well, what about if I take f of x and I do a minus c value here? So we can quickly see the starting points, ending points, and really what is this doing to the graph. If you want to add in maybe another slider here of doing a b value is usually kind of popular for right there. I have lots of parentheses. I don't need that one. There we go. So now you can see, well, here's the original function here in blue. And if I go ahead and, so we can just, moving this, I can see how I'm bringing it in. So right away, I can look at the transformation of trig functions, which is a great tool to use because we do a lot of transformations with algebraics, but then once we go to trig functions, we seem to kind of lose this idea here. And maybe just one more if I wanted to look at the amplitude here. I'll multiply by a, creating another slider here. And so I can see how the graph would get stretched. So right away here, you can get a nice visual picture. You can nice and bright colors. Get to see things move around and all of these things. Let's see, you could do like value of c comma 0 and actually make a draggable point. You could have students think about, well, if this is c comma 0, what is this point actually going to be? And maybe they would get that, well, you would actually have to take the period, all that, and see. Yeah, I can't think of all that right now. But so a lot of great ways just to get students kind of really exploring and using the math there. Let's see here. So I've looked at some trig. We've looked at, maybe we should just go to some basic, maybe pre-calc or just linear equations. Maybe you just want to just look at y equals mx plus b. Classic one to kind of start off with. You can say, well, what is the b value? You can look at the change of the slopes. If you want to kind of build like a little stair step type of thing, we do a whole bunch of graphs here, so they can ignore all of these. But down here, when you're first starting off, you can actually see that there are at the very bottom some just basic how to get started. We have parabolas, we have trig functions. If you want to get students to visualize some slope. So you can get this idea that the slope is 1 and 1.82 this way, and really getting that idea. If you think that this floor and stuff would just kind of really freak some people out, you can just say, I want to create a folder to hide these things. So you can go ahead and drag those over there so students cannot do that. All right, and so now you can kind of see that and get students talking about, well, how is the slope really changing? What is the slope? So you can use, if this was just developmental math, just looking at the rate of change, the slope. So it can work for just linear equations. If you want to do things in not just y equals form. So if you just want to do standard form, 2x plus 3y equals 8. Right? And right away, I am getting something graphed, so students don't have to worry about this idea of just solving for y. If you would still like them to practice those, so you can look at, see equivalent equations, 3y equals 8 minus 2x, right? Oh, looks like I have everything right because the blue is exactly the same as the green. Right? So they know right away. They are assessing themselves. they know right away if they're doing things right or wrong. If I did y equals 8/3 minus 2x, right? I just didn't divide the 3 over here. I can instantly see that my equation is wrong, right? So you can maybe ask students the question, are these graphs wrong? How could you make them right? What do you think the student's misconception is? So instantly you can get some great feedback, um, and you can still have the students be kind of just like working along. It will also solve some equations. So if you wanted just to look at something maybe like this, 3x squared minus 16 equals 12, then you could ask students, well, how could we really check to see if this is right? So you can maybe do like an intersection of graphs type of method. You could say, well, we could graph one side is y equals 12, one side is y equals x squared plus 3x minus. You could kind of zoom out here. Don't really see the intersection. Now I see the intersection points. Now it's pretty easy to find intersection points here in Desmos. You might be able to see that these are little gray dots, and I can just click on them and right away see that they are matching up. So the algebra that Desmos has solved, I can do the same over here. Notice that it's also giving me like the vertex and these x-intercepts. So again, you could do like a screenshot, put this on your test, ask some questions about it. But it's very simple just to get ideas, get information right away. You could also compare this to just saying, well, what if 0 equals x squared plus 3x minus 6 minus 12 equals 0. Oops, I already did that. So now we can see that these had the same values. You might ask students, well, why did it say 3, then -6, and then -6, or 3 over here? Ask what about 18? Would that give me the same thing? And so now I can graph this equation, and I can see x-intercepts. All right. So even though the calculator is doing a lot of the work, you can use it for students to quickly check their work, and basically ask a lot of maybe exploring questions a little bit. You could say, well, what about if this was equal to just C here? You know, what values of C would be that there would be no intercepts for this equation? So students can maybe kind of explore this a little bit, saying, okay, it looks like somewhere it's getting kind of close, around there, right? And so then students could actually maybe know that, well, their answer is going to have to be something negative. But you could say, well, what value would it be? How would you go about doing that? So it's more than just getting those answers. Start putting it in those slider values to really get students to start really exploring those ideas. So I have talked a lot about those things. I want to talk about adding some text. Let's see, I think I saw adding some steps to the slider. So yeah, you can add certain steps to the slider. So right now, if you look at 10, 10, you can do something if you want to just change it from -2 to 0. And that would define the slider a little bit more. Students like to do this just so that they can maybe hopefully get the exact slider value. We also had this idea just about adding text. So let me just show you a few things with that one. So I'll just start in class. I'll make a new folder. I say, okay, today we're going to be talking about some linear equations. All right. So maybe I'll first say y-intercept form. Oops, and I am doing a little bit of a shortcut there. It's hard for me to. I need to remind myself that not everybody sees what I'm typing. So over here, you can go ahead and just type in the text, but if you type in a quotation mark, that actually brings up the text box for you. So you could put slope intercept form. You can just put like y equals mx plus b. Right? You could kind of move on. You could say, okay, now that we've looked at that, we'll go ahead and start looking at some book problems. So when I am in class, I can actually use this to kind of organize my notes. Then I can save these. I can send them out to students that were not there and things like that. Um, so, oh, sorry. I was going to try to bring up a graph today. So here I had like a, my student was asking me about some derivatives of something, so maybe you don't teach calculus. But the student had a question. What was really nice that I was able to type in the math here and just give him some good feedback. I was able to go up here, copy that link, send that to him in an email, and then I was done. So it's a really nice way to answer students' questions, outside of the classroom, and the students also send me some questions. Wow, that's been a lot of talking. I guess I'll just look at one more here of making a new thing. I haven't showed you how you could insert an image. So over here is where you could insert an image. I will try to bring up a graph right here that has an image. Oh, here we go, CDC logo. So I was going to maybe have my students try to draw. So this is my community college, and it's going to have them maybe try to draw this logo here. So I went and just did like a screenshot of this logo, and you can go up here and just add image, and you can bring up this image from your desktop or that you have on your computer, and you can go ahead and bring it up. You have these features where you can make the image a little bit darker, or you can have it be transparent here. So it looks like what I was trying to do for this one is try to get students to kind of match up some polynomials here that would be able to draw the graph. Notice that with the image, you can drag these to make them smaller. You can drag them around to make them just move. And they also work with sliders. So if you actually wanted to import an image of somebody shooting a basketball, you put the image of the basketball. And let's see, I'm going to go ahead and make this move with a basketball here real quick for you. I'm going to do A, comma, F of, I'll do basketball, B of A. And so I'm going to make a basketball graph. B of x is equal to negative x squared. I'm going to go ahead and translate that to 3 plus 5. There we go. And let's see, I'm going to use my A slider. Oh, I must be using A somewhere else. Let me go back to here. A, capital A. So if you wanted to make like an Angry Bird, so I've done where students will take like an Angry Bird picture or a basketball, whatever you want them to be having them doing. They'll take that image and see how it actually, you can get that moving. It kind of brings some quadratics to real life. You can hide that if you want. So now you can see that my image is actually going to follow that parabola. So that's kind of fun. All right, so that was a very quick, probably overloading a lot of the features of Desmos. So John, I am going to take a break from the sharing of my screen of the graphing calculator here before I go into activities. Um, and John, did you see like any questions I needed to kind of answer from the group?
I feel like
I'm trying to.
you answer most of them, so you should be good.
Let's see. So just taking a pause. Let's see. Does anybody have like any thoughts, comments, questions, concerns? You might be saying, well, do you allow them to use this on a test? I am in a computer lab now, so my students they actually use Desmos as their graphing calculator. I think this is something that probably NCMatic and, sorry, that's mine, AMATIC might want to start looking at, what is going to be this thought about different technologies for assessment. Um, some things are getting ideas about um, the derivatives. Yes, so you can take the derivative of a function. You just do d of x. So if you wanted to do you would do dx in Desmos, and then whatever your function is, f of x. And so that would be how you would do the derivative. Needing to know how to use a TI for the next class at your institution. That's a great point. So what type of technology tools do we want our students to be able to use? Or if I have students going on to the next university, if they're transferring from my community college, should they be knowing how to use some TI? Should they know how to use Excel? We have not adapted just strictly Desmos yet in my department. I've had students in my pre-calc that were using Desmos, then they went to a teacher that did not use Desmos, and now they're back in calculus with me using Desmos. And the students to adapt pretty quickly. But this TI question is getting brought up a lot because like on a SAT, these assessments only allow students to use a TI, a Casio, a handheld graphing calculator. So people are starting to wonder, are we just having people use those TI calculators just because of assessment or things like that? But the use of technology for assessment is a great question, I think, for any department to be discussing. Yeah, and it does save some money. And if you use some open source technology for your textbook at a community college, AMATIC did some great ones there. I'm trying to think. There's a great free calculus textbook. So students could be using a free graphing calculator, a free textbook, and just have to pay for the course. And there's also free online assessment that people can actually use. Alrighty, so that was my first thing about just using the calculator. My next thing I want to look at is just looking at a few of the lessons that we have at Desmos. So at teacherdesmos.com is actually where we will explore next. And there's actually 4 different activities that we can start looking at. If people want to use them as a student, or if you just want to look at them as a teacher, that's fine. But I'm going to put up a code here. So if you want to go back and forth, if you want to open up a new tab, or if you want to open up a new window, you can actually use this as a student, and we will actually be able to see what you are doing. So, John, could you go ahead and bring me up the share screen again? Awesome. I see my share screen. Ready. I kind of moved on to my next one. So if I want to go back and see who is actually writing things, so I can actually look see what people have, what are people writing. Here is the AMATIC one that I just did. So you can kind of pair some people up, do some formative assessment. You can put all these together, have people pick which is the best one, why or why not. Can a man falls constant rate? Why when he plus parachute? All right, great job, Kelly. Thanks. All right. So really cool thing, and this pattern just kind of continues on. You have this one about bumper cars. You have this one about the Ferris wheel. So if you want to talk about some trig functions, you can bring this up. If you don't want to talk about trig, you just want to get the idea that a function can go up and down, right? So even my calculus students, when they first start off here, they'll try to maybe draw like a circle of this. And you're like, well, where's your cart? Oh, there it is. And you are way off, right? And the students don't really want to move on. They see this. It's okay to fail. Their mistakes is not a big deal. That they'll go back and just erase it and try and do it again. Some interesting things that I have done in my classroom, I think we would look at to say, well, if this was the ride, this is a picture of the ride, what would the ride look like? It definitely doesn't look like a Ferris wheel. So you can have the students get maybe creative and kind of make their own graphs over here. Right? So there is actually two parts to the function carnival. There's also a calculus version that you can do acceleration, do inflection points, and a lot of things like that. So that's the function carnival by Desmos. You can use it tomorrow. Great Friday activity, things like that. I'm going to go back to teacherdesmos.com. Wait, not the function carnival, classroom activities, and maybe one more. It's at 4:50. I think I have a few more times here. I'll look at the water line. Here is my next code if people would like to enter this one. This one is X2TV. So I'm going to go ahead and go back to here. X2, X2TV. I think that's what that was, X2TV. Okay. I'm going to go ahead and submit that one. And I'll go ahead and just do AMATIC again. So now with this one, you can get the students kind of thinking about, hey, how does the shape, so you can think about volume, surface area, how does the shape really determine the graph here? So we talk about this idea about it's a cylinder, so it's going just to be increasing at the same time, right? So again, you have these pop boxes. Notice that you can see how close you were, things like that. So it's a little bit that same flavor. What gets really interesting though is at the end here, when you start looking at different shapes. So now this really gets the students thinking about, okay, the container starts coming in on itself like a cone, but then it kind of comes back to that cylinder. What would that graph look like? So if you wanted to talk about this idea about increasing at an increasing rate and then a constant rate, or concave up, you can bring up those kind of mathy topics if you want, or if it's just a beginner level course, they can maybe try to challenge themselves to get those. Let's see, do we have anybody in the water line? Okay, Julie's in there, Brenda's in there. Nice, Andrea, Elaine. Looks like, yeah, so it looks like he's got there. So once you guys get back to this one, oh, here's the sphere. That's really cool. But this gets to my most favorite part, and that the students can actually create their own glass. So you can have the students be kind of creative and maybe make a certain glass for themselves. Right? But then the student has to then say, well, if you this is what you create, can you actually understand what you are creating? Oh geez, what do I have here? Okay, so this looks like it does something like this to this to this, and then maybe something like this. Oh, this is just terrible. Oh man, I'm way off. I know I am. Okay, so I'm gonna turn on my water, see how close I am. Not too bad. Oh, way too fast. I'm way too ahead of it. All right. So I finished way too early. But what's really neat, if the student actually gets it almost exactly, all right, so we're getting to that standard practice, that Common Core idea about being very precise, the students can actually take their glass and add it to the cupboard. And once it is in the cupboard, then you would actually see students that have really understood their glass, and then you can actually click on a different student's glass and try it out. So I really love that feature because it challenges the student to understand what they are making, and then students are then challenged of what they just made and who can make what's glass and who can actually make it to the cupboard. So it's a kind of a fun um, idea. Ooh, nice. We got a couple. John made like this kind of interesting graph over here. I'm going to go over here to the cupboard to kind of look to see what nobody's made it there quite yet, but Barbie's made some kind of interesting ones. But again, all of these here, you have a teacher dashboard. Again, you can look at the comments that people are typing in. Um, You can have where everything is filtered. So man, these lessons are just really perfect for a one-to-one, a one-to-two type of classroom. But you know, if you still just have the projector, you can show that up there. Maybe some student at your community college would bring a tablet. Maybe somebody would bring a laptop and kind of get like a group together. But it really gets the people engaged. Um, John, I think it's at 4:55, so maybe I have time for just one more here. I am going to go ahead and look at this penny circle. So this is kind of like a modeling activity. So here is my new one, CJK3, CJK3, CJK3. So we work a lot with Dan Meyer. Maybe you're familiar with his type of lessons in Act 1, Act 2, Act 3. Christopher Danielson is also really involved with these lessons. He is a community college teacher in Minnesota. So a lot of work has been going into these, trying to get like a good technology, but where students are really collaborative together. So here you have this penny idea. You get to see this video of filling in some pennies with a circle, and you're like, huh, getting this modeling idea down. All right, so you got that video, and now you get to see this. He starts filling in these pennies of a much larger circle to try to get students motivated. You can say, hey, what are some questions? Oh, one thing I didn't show you, when you actually start one of these, there's lots of teacher ideas behind the scenes that I've skipped. So when you actually create a brand new one, there's lots of teacher stuff for you to get ideas of how to use this in your classroom. All right, so you can just get an estimation. How many do you really think there are? I'll just put that there's 300. So they're like, what do you think that would be too low? You're like, I think 200 would be way too low. What number do you think is too large? You can say, well, I think 500 would be too large. So you're getting this idea about extrapolation and just trying to get a good sense of like number sense. Um, so you could kind of look at these average high guesses of when everybody gets theirs in. So it talks about modeling. So what the class then actually starts doing is that they build different circles, and they actually are doing the math as if they had the pennies right there on their desk. Um, so let's see, I can maybe squeeze, nope, oh, okay. can't really squeeze that one in. So the diameter was 2.8. The number of pennies was 7. I'll go ahead and add that. And so what you're doing, though, is that you're trying to get some ideas from some classmates here. Let's see. Was
And
anybody
Luke,
in
I
this
hate to interrupt,
one?
but I'm going to give you like a 1 minute warning.
So that is my 1 minute warning. Okay. So again, you get to hold the students' data points. Everybody works together, more data points, and you fit that model. Okay. But feel free to ask me questions. Hopefully you got a lot of stuff there. There we go, John. I am done. You can go ahead and stop sharing. How's the content out to help fund the calculator? And that's my work that will not be lost thinking about. No. Okay, go ahead.
Okay, well, if we could all thank Luke in the chat room again for this great presentation today, that would be great. And thank you to all of you for participating in today's AMATIC webinar. And if you'd like to support future AMATIC webinars, please consider becoming a member of AMATIC at bit.ly/join-AMATIC. And please remember to like us on Facebook at facebook.com/AMATIC. And recording of past AMATIC webinars can be found at bit.ly/AMATIC-webinars, and it typically takes us 1 to 2 weeks to produce and upload webinars to this archive. And this is probably the important part here. If you could please take 2 minutes to evaluate the webinar content in the presenter at bit.ly/AMATIC21. That would be great. And if you need email confirmation of your participation in this webinar, please fill in the optional section at the end of the evaluation. So I can see that there are a couple of questions that may still be going on in the chat room. So again, if you want to ask questions in the chat, that would be great. And if you want to just thank Luke again, that would be appreciate it as well. So thanks again, and I'm going to end the recording now, but I'm sure that Luke won't mind if you stay to ask a few